Condition in which a reaction can never be spontaneous is spontaneity of a reaction can be identified with the help of change in Gibbs free energy, delta G value, and this delta G value is equal to delta H minus T delta S. This is the equation. And with the help of this equation, we can say that a reaction can never be spontaneous if this delta G value is positive, and this value can only be negative in all conditions when this delta H is positive. It means endothermic process is that, and this delta S becomes negative. It means if this delta H value is more than 0 and this delta S value is less than 0, then in that particular case delta G becomes negative at all temperatures. That's why we'll choose that option in which this condition is given. Let's check where this is given here in option 1, and that's why this is the correct answer. Now after this, question number 87. pH of a strong acid solution is 2. What volume of water must be added to its 1 liter of solution so that the pH of new solution becomes 3? We know that pH is the negative log of hydrogen ion concentration. And if this pH value is 2, then definitely in this case, this H plus ion concentration is 10 raised to the power minus 2 molar. Now, in this case, what volume of water must be added to its 1 liter? It means for this solution, volume is also given. That V1 is 1 liter. And they are asking what amount of water is added to make the new solution with the pH value 3. It means when pH becomes 3, in that condition, this H plus ion concentration would be equal to 10 raised to the power minus 3 molar. And we know that molarity equation we can use to find out the volume of the final solution. Initially, the molarity of H plus ion or simply the molarity of the solution is 10 raised to the power minus 2. Volume is 1 liter. That should be equal to the molarity of next solution, that is 10 raised to the power minus 3, and V2 we need to find out. So this V2 would be equal to 10 raised to the power minus 2 divided by 10 raised to the power minus 3. It means this V2 value is equal to 10 liter. So how much amount of water you will add to it? The change in volume or the water added to the previous solution is equal to 10 minus already 1 liter was there, 9 liter. And where this 9 liter is given, it's given in option 4, and that is my answer also. Now after this, we have question number 88. For a reaction A plus 2B to give you 4C, equilibrium concentration of A, B and C respectively are 0.15, 0.10 and 0.2 mole per liter. Delta G for above reaction at 25 degrees Celsius is, in this case, we can find out delta G standard, that is equal to minus RT ln K. What is this K? This is equilibrium constant. And the reaction that's taking place here is A combined with 2B. The gaseous reactants are there and the gaseous product 4C are there. So what would be the value of Kc or simply K? That is equal to concentration of C raised to the power 4 divided by A, concentration of A, and then B raised to the power 2. The equilibrium concentrations of all these substances are also given. If we talk about C, it is 0.2 raised to the power 4 divided by, if we talk about A, that is 0.15 and then 0.10 raised to the power 2. So if you solve this for the value of K, you will identify that this K value is equal to 16 by 15. This is K value, the desired value. Now after this, we just want to find out this delta G value. Delta G value is equal to minus RT ln 16 by 15. This is the final answer, the final value of delta G as per this question. Now, temperature is also given here in the question, so we can also mention temperature. So, delta G becomes equal to minus 298 R ln 16 by 15. And this would be the answer that's given here in option 3. And that's why the answer for this question is option 3 also. Now, after this, let's take question number 89. pH of saturated solution of aluminum hydroxide is 9. The solubility product Ksp of aluminum hydroxide is, as we know that the pH is equal to negative logarithm of H plus ion concentration, and if for this solution this pH value is given, that is 9, so definitely this H plus ion concentration would be 10 raised to the power minus 9. And if it is so, this OH minus ion concentration you can find out, that is equal to 10 raised to the power minus 14 divided by 10 raised to the power minus 9, and it is equal to 10 raised to the power minus 5. Now, once again, the substance that we have here is aluminum hydroxide, solid. We have aluminum ions are formed plus 3OH minus. This is as per the given equation. Now we can write it as the solubility of aluminum ion S and the solubility of hydroxide ions 3S. But 3S has the value that is equal to 10 raised to the power minus 5. So what would be the value of S? That is 10 raised to the power minus 5 by 3. Now if we have this value, we can find out the Ksp also. Ksp is equal to S into 3S cube, or simply it is equal to 27 S raised to the power 4. And that's why this Ksp is equal to 27 into 10 raised to the power minus 5 by 3 raised to the power 4. And this value on solving, you will get here 1 by 3 into 10 raised to the power minus 20. And this value, the answer that we obtained here, is given in option 4. And that's why this is our final answer, option 4. Now after this, there's the last question. Question number 90. SO2 and helium gases present in 2:1 molar ratio in a closed vessel are allowed to effuse. The average molar mass of the initially effused gaseous mixture is. It means we are talking about the effused gaseous mixture that has effused from that reaction mixture. So we have the two gases and we know that rate of effusion. Suppose we are talking about rate of effusion of SO2. The ratio I'm taking here to the rate of effusion of helium, that should be equal to the root of molar mass of helium upon the molar mass of SO2. But we have taken these gases in 2:1 molar ratio, so that will also affect this, and it would become 2 by 1 because the ratio was 2:1, that's why. So this rate of effusion of sulfur dioxide to the rate of effusion of helium is equal to 2 into root. Molar mass of helium is 4 divided by molar mass of SO2. If we talk about, this would be 32 plus 32, 64. Or simply it would be 1 upon 16. So this would be equal to 2 by 4, that is 1 by 2. So the rate of effusion will be 1:2. It means one part of SO2 is effused out while 2 part of helium would be effused out. Now we should find out the average molar mass. So the molar mass, that is average we are taking here for the effused gases. One part of SO2 is effusing here. One part of effusing SO2 means 1 into the molar mass of that SO2, 64, plus 2 part of helium is effused, that's why 2 into 4, divided by the ratio that is 3, divided by the sum of the ratio that is 3. Further, 64 plus 8 by 3, that is equal to 72 by 3, 24 gram per mole. This is the average molar mass of initially effused gaseous mixture, and that's why the correct answer is option 3. I hope all the questions of this paper are clear to you. All the best for your results. Thank you so much.